My name is Jolese Witbooi and I'm a student at Automation Works and Training Facility. This is my project for the first term. The problem I identified was waste and tiny pebbles as a harmful effect on garden aesthetics and soil quality. What motivated me to do this design was I've always been annoyed by waste and contaminants that comes with gardening. Problem statement. To design and build a mechanical sand purifier which will efficiently remove small pebbles and unwanted waste from sand, ensuring clean fine sand for gardening and private gardening and landscaping activities without using electricity. Solution process. I looked into related designs. I compared costs, materials and their effectiveness. I also improved my design by making it much smaller. Real-world applications. Landscaping. To purify sand for landscaping activities. Gardening. To provide clean sand for private gardening. Playground maintenance. To purify sand for playground playboxes. Potential impact and benefits. Cost saving. Gardeners do not have to buy new soil every time. It reduces waste. And by reusing and recycling sand, we can save natural resources. Essential technical elements of my project. The cylindrical drum the drum is a cylindrical design with 10 by 10 millimeter holes in the mesh. The rotation mechanism has a mechanical crank for rotation. The frame is for steady support and the wheels is for mobility. I used steel poles because of its strength and it can be easily welded. Welded wire mesh for efficient separation and it reduces the overall weight. The technologies that I used was a 3D printer and Fusion 360. The processes that I used was welding. What do I see as unique in my design? It has wheels so that you can push the mechanism to your desired location. Welded wire mesh instead of woven mesh. It has minimal maintenance and the mechanical sand purifier does not use any electricity. So this design uses a DC motor. This is my hand sketches, this back view and top view. This is the front view. So it's the cat sketch, what I mentioned. Okay, so this is the mechanical crank for rotation, the frame and the drum. Okay. Alternatives that I considered, wood poles, because it would be much cheaper. Nylon wheels to move across rough terrain, and a mesh that is welded to a flatbed mesh. So yeah, this is what I mean by a flatbed mesh. It is welded to the surface and this was also my first design. I 3D printed a part to see if it will fit into the material. This was the first print and this is the final product. The tools that I used was a grinder and a welding machine. I used MIG welding. I also used a 3D printer. The new tool that I used was welding. This is important for me to know in the future as it creates job opportunities. It is a useful ability for artistic expression and it improves my DIY and repair skills. The skills that I needed to demonstrate was design and planning, and by thinking carefully, I decided which materials I want to use based on their effectiveness. Technical drawing as well as modeling. I used Fusion 360 to create a CAD model of my design. The new skills that I learned was welding. I learned a welding technique and safety protocols. Assembly sequence. My first step was to create a CAD design of my project. I chose materials based on their effectiveness and costs. My third step was to weld everything together. And lastly, I tested to see if it will work. My research influenced my design by using a rotary mesh instead of a mesh that is welded to the surface. The size of the mechanism. Identifying areas where I can make the design better. And the mesh size, as different mesh sizes can be used for different types of waste, like small pebbles, big rocks, weeds, twigs. How my design will work. Recent research on the mechanical sand purifier was in 2023. The research is relevant to gardeners and it includes websites like Nevin Project, Self-Sufficient Me on YouTube, and Marco Industries. This information is reliable as it comes from research papers, and the purpose of the research is to educate people more on the mechanical sand purifier's benefits and how it works. PPD, activity log and acknowledgements. I spend most of my time on the tutorial project and my design project. The rest is extra work I did, practical on Wednesdays, and PPD. The main points in PPD this time was arguments, statements, and structural fallacies. The topics that stood out for me the most was how to identify fallacies, and a difference in opinion is not always an argument. This improves my day-to-day interaction with people, as it allows me to identify incorrect arguments. It helps me to focus on the argument rather than the person, and I am able to have more respectful conversations. Technical difficulties. My first design suited commercial industrial and was too dangerous. And it was also too big. The changes that I made was using a rotary mesh, casters, and making the design much smaller and lighter to make it more accessible. The lessons that I learned was to use more than 2 resources for designs and researches. Make the new design more cost effective and take accurate measurements. I can improve my design in the future by motorizing it. I can also use different mesh sizes, like I said, for different types of waste. So the overall price of the mechanical sand purifier was 571 Rand and 13 cents. I spent 4 hours and 30 minutes on 3D printing and 18 hours on building the product. Yeah, this is how it works. Acknowledgements. Nevin Projects, Nick and Nick's Printing Shop, Marco Industries, Self-Sufficient Me on YouTube, Delano, Tani Elmarie and Umzaisi. So yeah, this is some of the coursework that we did. This is the distribution panel and flow sensor. Okay, so. Okay, so each one of us needed to create a website to store our evidence. So this is the first mechanical. We did theory on Fusion 360 for 4 weeks, and Wednesdays we had practical with David and the other guys. So yeah, our first assignment was mounting brackets and measured and sketched. Okay, then a distribution panel. Yeah, the flow sensor, a shape activity, and the first picture is a CAD competition that we had. Okay, so yeah.